Hey y'all! In this video, we're going to explore how to create transactions, how to sign them using a private key, and how to broadcast them to the network using Viem. In the last video, we took a look at how to use Viem's public client to access read-only operations on the Ethereum network. This allows us to read values such as the last block number, retrieve transactions, and read data from smart contracts. We'll explore more of this in later videos. What we want to do today is introduce another type of interface for changing state on the blockchain. In this example, we're going to keep it simple. We're going to just be creating a transaction and transfer some ETH between two addresses. In order to achieve this, we need to introduce this idea of a wallet client. So I'm on the Viem website now, and in the last video, we took a look at this public client. Now the public client, it gives us access to an Ethereum node's JSON-RPC API, but it only gives us access to the public methods. So these are methods that allow us to just read values. We can't actually change anything. In order to change anything on the Ethereum blockchain, we need to sign transactions with a private key or an account that we have on the network. Now, in order to achieve this, we have this idea of a wallet client in Viem. And wallet clients give us the capability to be able to interact with accounts. So this gives us the capability to sign transactions, call smart contracts, and do everything that we'd want to do on Ethereum if we were changing any information. What we want to do today is simply just transfer some ETH from one account to another. Now, before we dive into the code, I do want to take a step back and just discuss what exactly this layer of software really interacting with. So really what's happening here is that everything that we're using here is really an abstraction layer on top of the ETH1 JSON-RPC spec. So this is what's on my screen here, and these are going to give you all of the different endpoints that may or may not exist depending on the Ethereum node we're interacting with, their configuration. But things like ETH underscore accounts, estimate gas, fee histories, get balance, these are all endpoints that are part of the standard JSON-RPC API that all Ethereum nodes implement. So there's different implementations of these, but the endpoints from us as developers are consistent. So we don't really have to worry about what implementation we're calling into. We just call into the ETH get logs endpoint and we can get data back. So when we're speaking about Viem and what we're really using up here at this level, it's really an abstraction layer on top of this JSON-RPC API. So let's go ahead and dive in. So if we go to our code here and we take a look at what we have so far. So far we just have a client in our config.js, and that client is being exported. This is a public client connecting to the Holsky network. Okay, so in addition to the create public client, we also want to create a wallet client. Now this wallet client is going to give us the capability to call into write endpoints on an JSON RPC node. So we're going to go ahead and say create wallet client. We're also going to want to bring that in up here. So we'll go ahead and say create wallet client. Okay. And the chain is going to be Holsky and transport. Now, because this is basically a command line application at this point, we could use, if we were running this in a browser, we could use the window.ethereum, which is the injected wallet that, say, something like MetaMask may provide us. But in this case, we're just going to use an HTTP transport to be able to achieve this because we're running this just on the command line. Now, that's going to give us our wallet client. You know what we could do too? Instead of exporting it like we were down here, we can go ahead and export like this, and this we'll have to import these a little bit differently, but that's okay. Whoops. We are going to want to export these like this, and we'll take this out. Now, with our wallet client exported, we now also need one last piece. We do need an actual private key. Because we're using this HTTP transport, we are not going to be using the facilities of an injected wallet to be able to sign transactions, we do need to provide an account ourselves. So what we can do is this is kind of nifty. I like to do this when I'm just testing things out. Any 256-bit random value could be used as a private key. So what we can do is we can create an account by creating a private key. We can create a private key by just creating a random 256-bit value and then inputting that into a little function that Viem exposes for us called private key to account. So what we can do is we can export const account, and we're going to say it's private key to account. And now inside of here is where we're going to put private key. Now be super careful here. I'm just using a throwout value for this, but I am going to be pasting in a private key here. You don't want to do this in practice if you have any private keys with actual value on them, because you'll be saving the private key here right onto hard disk. So we do need to bring this into our project up here. So this is part of the Viem accounts package. So we're going to say private key to account, and from the Viem/accounts. Awesome. So now we need to create a private key. Now this is super easy if you have OpenSSL installed. So I'm going to go ahead and go here. So we could say OpenSSL rand hex 32 bytes. And that's going to give us a random 256 bits in the form of hex. So I could just go ahead and copy this. And now that is a private key. We can use that for an account. Super cool. Okay, so now we can put this right into here. We do need to prefix this with 0x and put that in there. And now we have our private key. So now our configuration consists of our client, our wallet client, and our account. So this is really the public client. We could probably rename that to PublicClient. So now this little configuration is exporting 3 different tools for us. We do have a private key in here, which we're going to use as our test account. And now we can go ahead and head over to our index, and now we can start to use this. So now instead of importing our client, we're going to import client, and we're going to import the wallet client, and we're going to also import the account. Awesome. Now this should technically still work. So if we go ahead and run this, we can go ahead and just say boom, there we go. We're still running. That's a good thing. Okay, so now that we have our wallet client, we can now start to create transactions, which is really cool. So there's really 3 things that we're going to need to be able to create a transaction. It's really just the from and to and the value. So super easy. Now we are going to need to put a little bit of ETH into this account, because we don't actually have any ETH in it. So we're going to have to pay for some gas if we want to be able to send transactions. So what I'm going to do is I'm going to go ahead and just send a little bit of ETH to this account. Now, how do we know what address to actually send this to? So what we need to do is we need to get the public key from this account. Now, if we just take this account and we say console.log account here, and I'm just going to take this out for now. We don't need to output all the stuff. And we run this. Oh, did we not export this? So let's go back. Export const account. We did. Did we not save it? You gotta save it. Okay, so let's run this. Okay, there we go. So we do have an address here inside of this object, and you can see that here is our address. So if we go over and we go to, remember we're on a test net, so we're gonna go Holsky Etherscan, and we plug this in. This should be a fresh address. Awesome. So now I've got some test ETH here that I'm going to go ahead and send to this address. So I'll just go ahead and send a little bit of ETH here. Got a bunch of test ETH we could play with. And I'll go ahead and send 1 ETH over to this address. Okay, I just sent a little bit of ETH over. Okay, so now we have 1 ETH in this account, which is awesome. And now we can go ahead and send some ETH around. So let's go back to our program here. And we can come out of this. And now that we have this in place, we don't really need to do this anymore. We're just going to be working with the wallet client. So I'm going to take this client out for now because we're not going to use it. And we're not going to use this. So our program's looking pretty bare right now. Now we're going to do these three things. First, we're going to prepare a transaction request. Okay, so we're going to prepare our transaction. Now we're going to do this by using the wallet client's prepare transaction request method. So to do this, we're going to say const request, and we'll say await wallet client dot prepare transaction request, and this is going to take an object. Now that object is going to have the to value, and we won't put that in there just yet. It's going to have the value, which we can. This is the value in way. So what we can do is there's a convenience function that Viem exposes. I believe it's called parse ether. Let me just go ahead and take a quick look at that. Yes, it's parse ether. So if we wanted to say parse ether, and then we can give it a string value of, say, we'll send like 0.5 ETH. And now that should translate to the way value. So we do need to import that. It's going to be imported as parse ether, and that's coming from Viem. Okay, awesome. And I think we do also need to, the third piece of this is going to be where it's coming from, which is going to be our account. So all we have to do here is put in the account. Awesome. Now the to address, I'm going to go ahead. I have an account that I have for testing. I'm just going to go ahead and grab that address. And let's go ahead and put that in here. Okay, awesome. So now we should be able to prepare this request. Now if we go ahead and try to run this, I'm going to console.log the request. And let's see what this looks like. Okay, awesome. So it looks like we have a prepared transaction. We have a value here. We can see this is in way. Its to and from is looking good. The chain ID is looking good. It is a 1559 transaction. It did fill in a couple other values that we didn't have to fill in, but we could fill in ourselves if we want, things like the nonce and stuff like that. But this is looking good. So now the second step of this is going to be to sign the transaction. So let's go ahead and sign this bad boy. So now that we have the request, we can go ahead and sign it. So to sign it, we're going to just use the sign transaction method on the wallet client. So we'll go ahead and say const signature is equal to await wallet client dot sign transaction. Gotta spell transaction correctly. And that's just going to take in the request. Easy as that. Now, if we do a console log of our signature, we should see that we have, boom, here's a signed transaction. Now, you technically could just take this value and broadcast it. You know, we could broadcast this, say, using, let me pull this up real quick. So on Etherscan, there is a broadcast raw transaction. We could technically go here, just paste this in and broadcast it, and it should work. So we could take this transaction and generate this really offline in a sense. Like right now, our program has a private key in it. You may not want to do that when you're online. So if you generate that transaction and you have that object and then you sign it offline, you can then have a signed transaction using that private key without exposing your private key. So it's pretty interesting information there. Now we're not going to go ahead and do this. We're not going to broadcast it here. We're going to broadcast it right in our program. So if we go back to our program and we take a look at what we need to do to broadcast this. So now we have a signed transaction. Now we want to broadcast it. So now to broadcast it, we're just going to send a raw transaction. So we're going to say constant. Whoa, what happened to the last one too? Now, as a disclaimer too, I am kind of learning this new Viem setup, so I'm a little all over the place with my Viem configuration. I'm hacking away at it, and I'm learning a lot of the key bindings. So it may look a little messy now, but hopefully it's coming out smooth. So we say constant hash, and we're going to say await WalletClient.send raw transaction, and we're just going to give that the signature. Boom. And that should be it. Now, this should give us back the hash value of the transaction, and it should broadcast it to the network. So this should be all we need to be able to create a transaction, sign the transaction, and broadcast that bad boy to the network. So let's try to go ahead and execute it. Uh-oh, we got an error. So let's see. No string into go value bytes. Invalid argument 0. JSON cannot unmarshal non-string. So it seems like this signature is serialized, which means that we have to pass this in as an object in order for us to get this to go. So let's try this. We have to pass this in as an object like this, and this should satisfy the requirements of what send raw transaction is looking for. Let's see if this works. So let's go ahead and try to run this bad boy. Nope, it doesn't like that either. Because so this is interesting. I think I may have found a little bit of an issue with the documentation. Prepare transaction request. So this parameter here, if we look at the definition of the send raw transaction, we're going to call this serialized transaction. Right. And then here, we're just going to go ahead and put serialized transaction in this. Okay, because the keys in this send raw transaction is expecting a serialized transaction property in that object. So that's probably what's causing the issue here. So let's see if that is in fact correct. Boom. Okay, I think that worked. We didn't output the actual hash. So let's see if we go back to Etherscan, we look at our, I'm going to zoom into this a little bit so you can see it a little better. So we have the ETH coming in, and now if we go ahead and refresh this, we should see if we had a hash, we would see if that went through, but we could keep track of the transaction. But let's see, is there any way to, and boom, there we go. So now we just successfully transferred a half an ETH out back to this address. So we should see 2 transactions. There we go. Now, if we wanted to do this again, we still have 0.49 ETH in here. So I'm going to go ahead and transfer 0.48. Let's go ahead and do this one more time so we can actually get the transaction hash, and you can see it going down here. So I'm going to go ahead, instead of 0.5, I'm going to say 0.48. And I'm going to go ahead and output this hash. Okay, so the thing that we learned here was that this needs to be called serialized transaction, or at least the key in this object to send raw transaction needs to be serialized transaction. I'd be curious if anybody has any insight in the comments as to if there's any other ways to do this, or if there's any explanation as to what the serialized transaction, what does serialized mean in this context. But let's see if we can just go ahead and transfer this again. So we're going to say console.log hash, and let's run it. Now we should get a transaction hash here, which we have. Awesome. So I'm going to grab this. Now if we go here, we should be able to now see the transaction hash. And there we go. 7 seconds ago, 0.48 ETH. Oops, I'm not on my, there we go. 0.48 ETH, and it looks like it worked. Nice. And now we only have 0.01 on this account. Excellent. All right, so that private key is out in the open. If anybody wants to go and grab that 0.01 ETH, it's there for the taking. But awesome. So this seems like it worked. So what did we learn in this episode here? So a couple things. We did look at the 3 pieces you need to be able to create a transaction, sign a transaction, and send a transaction, right? So prepare a transaction request, sign transaction into a serialized transaction, and then pass that serialized transaction into a send raw transaction. Awesome. So that is looking good. So I think in future videos, what we're going to do is we're going to build on top of this. We're probably going to look at how do we interact with smart contracts using this same setup, because now with this wallet client setup, we're able to really interact with the entire network and send transactions and interact with smart contracts. So in the future, we're going to start to play with some smart contracts. All right, guys. Thanks. Talk to you later.